In this video, I'll be going over problem number 10 in exercise number 1, 6.5. 6.5, exercise 1, problem number 10, which introduces the concept of mini truth tables. So this is the last twist here in exercise number 1 before we move on to exercise 2, mastering the mini truth tables. So I've gone ahead and set up the problem here by writing it out, first of all, horizontally, separating out the premises with a single slash, and the conclusion with a double slash. Further, I've gone ahead and taken on our original assumption that the premises are true and the conclusion false, therefore defining it as being invalid. So given this assumption, as always, I want to know, is there anything else, any additional information that I can figure out with respect to the variables or other operators for that matter in the problem? So I'm just going to jump in here examining the first premise. Main operator in the first premise is the horseshoe, of course, and I've defined it as being true. So given that information, can I know anything about M, N, O, or for that matter, even the wedge? By consulting your truth table, you'll see that there are, of course, 3 different ways for a horseshoe statement to be true. We don't know which is the case. Could be T horseshoe T, could be F horseshoe T, could be F horseshoe F. We really don't know which just yet is in fact the case. So we seem to be in an impasse when it comes to premise number 1. And in fact, by examining the other information given to us in the argument, by examining the other individual premises, we'll see that the same holds true for them as well. Main operator in each of these is of course the horseshoe, and we've assumed all of them to be true. Given that there are 3 ways for a horseshoe statement to be true, we can't really know much of anything here. So now let's turn our attention to the conclusion and see if we can figure anything out there. The conclusion, of course, we define as being false, and the main operator is the triple bar. However, by consulting your truth table, you'll once again see that there are 2 ways for a triple bar to be false. Could be F triple bar T, or the other way around, T triple bar F, and we really at this point don't know which to be the case. So by examining the entire problem, we seem to be stuck. We seem to be at a complete impasse. And when that occurs in exercise 1, and this will be the same in exercise 2, on either of the 2 exercises, when you reach an impasse, when you get completely stuck, you are to construct what's called a mini truth table. We're not going to go to the trouble of constructing a full-blown truth table, as we did in earlier sections by counting up the number of unique variables, plugging that into our formula. As you can tell here just by looking quickly at problem number 10, to do so would be quite time-consuming. That'd be a really lengthy problem. So instead of constructing a full-blown truth table, we're going to again construct a mini truth table. We're going to construct a mini truth table just for either one of our premises or, if we choose, for the conclusion. So the question, quite obviously, is, do we want to construct a mini truth table for the first premise, the second premise, the third, the fourth, or for that matter, the conclusion? And unfortunately here in 6.5, there isn't any hard and fast rule. If you always construct the mini truth table for this premise or the conclusion, then it'll work. So no hard and fast rules, but I can give you a general rule. And by general rule, I mean if you generally pick the conclusion to construct your mini truth table with, then it will generally work. Can't guarantee that it'll always work for you. And what you really need to think about in constructing your mini truth table is the following. If I had this additional information to work with, would it prove useful in unraveling the entire problem? Further, in addition to that, think about which of the premises, or the conclusion for that matter, which of these would it be easiest to construct a mini truth table for? And again, in this case, you'll see that it's probably going to be easier to construct a mini truth table for the conclusion as compared to any of the premises. All of the premises are complex, involving at least 2 operators, whereas the conclusion, only a single operator. Further, there are 3 ways for the premises to be true, but there's only 2 ways for the conclusion to be false, making it a little easier to work with. Finally, you'll notice that N and O respectively, the 2 variables present here in the conclusion, appear many times throughout the rest of the problem. So I think that if I knew N and O, I would in fact be able to unravel the rest of the problem. Alright, so I'm going to choose to construct my mini truth table for the conclusion. But again, that's just a general rule. I can't guarantee you that it will always work. Before you choose to construct your mini truth table, try to think again several steps ahead. It looks like it's going to work for the conclusion, so let's see if that's actually the case. In constructing my mini-truth table again, I'm going to, in this case, go through all the logically possible ways for this conclusion to be false, of which there are just two. In no particular order, it could be the case that N is true, where O turns out to be false. And the only other way for that triple bar to be false is where N is false and O is true. So those are the only two logically possible ways, again, for that conclusion to be false. And I'll go ahead and extend my truth table down that second line, continuing to, in line number 2, define all the premises as being true. So that completes my mini-truth table. Quite obviously, this will be much, much shorter than going to the problem, going to all the trouble of constructing a full-blown truth table. Here I've just got 2 lines to work with. It does, however, make my problem a little longer, in that instead of just dealing with 1 line, as we were doing with the other indirect truth tables, in my mini-truth table, in this particular case, I now have 2. In some cases, you'll have 3 lines in your mini-truth table. So I'm just going to treat these as 2 separate problems. First dealing with line number 1, where I define N as being true and O as false. And then if I need to, I might have to go on to line number 2, where N is false and O is true. What I'm looking to do here is to avoid a contradiction. As soon as I avoid a contradiction on some line, I can stop. I'm done with the problem. If I avoid a contradiction, what that tells me is that it is possible for my assumption to be the case. It is possible for all of the premises to be true and the conclusion false. Therefore, again, if I avoid a contradiction, I know it to be invalid. I can stop right there. If, however, I reach a contradiction on the first line, that means that I have to go on to the second line, where again, N is false and O is true. If I reach a contradiction, on to line number 2. If I reach a contradiction on my last line, then what that tells me is it's impossible for the conclusion, or for the premises to be true, where the conclusion is false. Therefore, it's the opposite of my original assumption, therefore it's valid. So again, what I'm looking to do is avoid a contradiction. As soon as I avoid a contradiction, I'm done. So I'll go ahead and let you finish the rest of the problem. Sometimes you get lucky depending on how you set it up, and in that you avoid a contradiction early, and there's no need to go on to line number 2. So again, finish up problem number 10 on your own, and then check out your answer.